Hi all, this is Bharat. I'm studying BTech first year, second section, CSA section. Our roll number is 219518052. Today my topic is about LED construction. In this overall PPT, we will see how LED will be constructed. First of all, the LED means light emanating diode. What is light emanating diode? The light emanating diode is a PN junction diode. It is a special doped diode and made up of special type of semiconductors. When the light emits in the forward bias, it is called a light emitting diode, that is LED. In this picture, we see the LED. It is the LED. Now, the LED symbol. The LED symbol is similar to the diode symbol, except from the two small arrows that specify the emission of light. Does it called LED? That is light emitting diode. The LED includes two terminals, named anode, that is plus, and cathode, that is minus. The LED symbol is shown below. This is the LED symbol, and this is the symbol like only diode, but in the LED we have two small arrays that specify the emission of the light. It goes out, and it's anode and cathode. This is the symbol of the LED, that is light emitting diode. Now we'll see the construction of LED. The construction of LED is very simple because it is designed through the deposition of three semiconductors materials layers over a substrate. These three layers are arranged on one by one, where the top region is a P-type region, the middle region is active, and finally the bottom region is N-type. The three regions of semiconductors can be observed in the construction. In construction, the P-type region includes the holes, the N-type region includes electrons, whereas the active region includes both holes and electrons. When the voltage is not applied to the LED, then there is no flow of electrons and holes too, so they are stable. Once the voltage is applied, then the LED will forward bias. So the electrons in N region and holes from P region will move to active regions. This region is also known as repulsion region. Because the charge carriers like holes include a positive charges, whereas electrons have a negative charge, so the light can be generated through the recombination of the polarity charges. Now, how does the light emitting diode works? The, the light emitting diode, that is LED, simply known as diode. When the diode is forward biased, then the electrons and holes are moving fast across the junction and they are combined consistently removing one another out. Soon after the electrons are moving from N-type to the P-type silicon, it combines with the holes, then it is disappears. Hence it makes the complete atom and more stable, and it gives a light burst of energy in the form of teeny packet of photon of a light. The above diagram represents the working of light emitting diode. We can see that the red color denotes the N type and the blue color is P type, and there is a battery that is negative to positive. And we will see the above diagram shows the how the light emitting works and the step by step process of the diagram. From the above diagram, we can observe the N-type silicons is in red color, including the electrons, which are indicating by the black circles. The black circles indicates the electrons, and red is N-type. The P-type silicon is in blue color, and it contains holes also. They are indicated by a white circles. The power supply across the PN junction makes the diode forward bias and pushing the electrons from N-type to P-type. You can observe in a diagram that is pushing N-type to P-type. The pushing holes in the opposite direction. The holes are pushing in opposite direction, and electrons and holes at the junction are combined. The photons are given of electrons as and holes are recombined. Now the light emitting diode circuit for bias. Most of LEDs have voltage rating from 1 volt, 3 volts, whereas forward current rating range from 200 milliamperes to 100 milliamperes. Now in this diagram, it shows the LED bias, that is light emitting biasing. The, in in this diagram, we can observe that the flow of electrons, electron current is flow. In the voltage, 1 also 3 volts is applied to the LED, then it function properly due to the flow of current for the applied voltage will be in operating range. Similarly, if the applied voltage to the LED is high than the operating voltage, then the depletion region within the light emitting diode will break down due to the high flow of current. This unaccepted high flow of current will damage the device also. This can be avoided by connecting a resistor in a series with a voltage source and an LED. The safe voltage rating of LED will be range from 1 volt to 3 volts, whereas safe current rating range from 200 milliamperes to 100 milliamperes. Hence, the resistor which is arranged in between the voltage source and LED is known as the current. Limiting resist because the resistor regulates the flow of current, otherwise the LED may destroy it. So the resistor plays a key role in protecting the LED. Mathematically, the flow of current through the LED can be written as IF equal to Vs minus Vd by Rs, where IF is forward current and Vs is voltage source and Vd is the voltage drop across the light emitting diode, that is LED, and Rs is current resistance. The amount of voltage dropped to defeat the barrier of the depletion region, the LED voltage drop will range from 2 volts to 3 volts. Well, let's say an GE diode is 0.3, otherwise 0.7 volts. Thus, the LED can be operated by using high voltage as compared with SI or GE diodes. Light emitting diode consume more energy than silicon or chromium diodes to operating. Now, working principle of LED. The working principle of LED is based on the quantum theory. The quantum theory says that when electrons come down from the higher energy level to lower energy level, then the energy emits from the proton. The proton energy is equal to the energy gap between these two energy levels. If the PN junction diode is in the forward bias, then the current flow through the diode. In this picture, we can observe that working principle of LED. In this picture, in blue we have see P type, in like orange it is N type. Uh, the the whites are white symbols are volts, and the orange is electrons. This is the light. This is a, this is a conducting band. This is the valency band. This is the band gap, that is 4 pn gap, also called energy gap. The flow of current in semiconductor is caused by the flow of holes in opposite direction of current and the flow of electrons in the direction of the current. Hence, there will be a recombination due to the flow of these charge carriers. The recombination indicates that the electrons in the conduction band jump down to the valency band. When the electrons jump from one band to another band, the electrons will emit the electromagnetic energy in the form of photons, and photon energy is equal to the Fourier energy gap. That is energy gap, we also know. For example, let us consider the quantum theory. The energy of the photon is the product of both the Planck's constant and frequency of the electromagnetic radiation. The mathematical expression is known as EQ is equal to HF, where is known as Planck's constant. The velocity electromagnetic radiation is equal to the speed of the light, that is c. The frequency radiation is related to the velocity of the light as an F equal to c by lambda. The lambda is denoted the wavelength of the electromagnetic radiation, and above equation will become as EQ equal to He by lambda. For the above equation, we can say that the wavelength of the electromagnetic radiation is inversely proportional to the uh, Fourier gap, that is energy gap. In general, silicon, germanium, semiconductors, these forming energy gap is between the condition and valency band are such that the total radiation of the electromagnetic waves during recombination is in the form of infrared radiation. We can't see the wavelength of infrared because they are out of our visible range. The infrared radiation is said to be uh, it because the silicon and germanium semiconductors are not direct gap semiconductors, rather they indirect gap semiconductors. But in the direct gap semiconductors, the maximum energy level of the valency band and the minimum energy level of the condension band does not occur in the same amount of electrons. Therefore, during the recombination of the electrons and the holes are migration of the electrons from the condition band to the valency band, the moment of the electrons band will be changed. Now we will see multicolor light emitting diode. A light emitting diode that produce one color once they connected in a forward bias and produce a color once they connected in a reverse bias is known as multicolor LED. Actually, these LEDs include two PN junctions, and the connection of these can be done in a parallel with the anode of the is linked in the cathode of the another. Multicolor LEDs are normally red once they bias in the one direction and green once they bias in another direction. If these LEDs turned on very fast among two polarity, then these LED will be generated a third color. A green or red will be generated a yellow color light ones rapidly switched backward and forward among bias properties. Now we will see the IV characteristics of LED. There are different types of LED are available in the market, and there are different LED characteristics which include the color light or wavelength radiation light inside. The important characteristic of LED is color. In the starting use of LED, there is only red color. As the use of LED is increased with the help of the semiconductors processing and doing the research on the new metal for LED, the different colors are very formed. Also, you can observe the graph. We have different colors, types of colors of LEDs. In x-axis we have voltage. In y-axis we have current. That is IV characteristics. Now, what are the two types of LED configurations? The standard configuration of LEDs are two like imitators as well as COBs. The imitators is a single die that is mounted towards a circuit board, then to a heat sink. The circuit based board gives electrical power towards the imitator. We're also drawing away heat. So the design is called as COP. That is chip on board array. The advantages of light imitating diode include the following. The cost of LED is less and they are tiny. By using the LEDs, electricity is controlled. The intensity of LED difference with the help of the microcontroller. The LED have long lifetime. They have energy efficiency. No period doesn't affect by cold temperature. Color renderness is excellent, environment friendly, and controllability. The disadvantages of LED, that is light emitting out, include the following: price, temperature sensitivity, temperature dependence, light quality, electrical polarity, voltage sensitive, and effective drop and impact on insects. This is the advantages and this is the disadvantages. Once observe them. Now the applications of LED. There are many applications of LED. Some of them are explained below. LED used as bulb in the homes and industries. The LED are used in motorcycles and cars. These are used in mobile phones to display the message. At the traffic light signals, LED are used. And thank you. This is the construction of LED and the advantages, disadvantages, and we cover almost all topics about LED. Once just recollect the PPT. First we discuss what is LED, then LED symbol and construction of LED, and how LED works, and we will discuss that light emitting diode current bias. Then we will discuss working principle of LED also, and multicolor LED and IV characteristic of LED and the types of LED configurations and advantages and disadvantages and applications of LED. Thank you.